Hey everyone, welcome back for another deep dive. Today we're going deep on some seriously cool AI research.
Oh, yeah.
The 8th AI City Challenge.
This is a good one.
Yeah, this is where like all these brilliant minds get together
Hmm.
and they're using AI to try to solve real-world urban problems.
Yeah.
And we're talking about making our cities safer, more efficient, all
Yeah.
the kind of stuff you usually only see in like sci-fi movies.
Yeah, it's really cool to see like all this technology going from like theory to practical application,
Yeah,
stuff that we could see in our cities pretty soon.
totally. And to guide us on this journey, we've got excerpts from the official research paper. So we can really
Slacker.
like unpack all the most like fascinating breakthroughs
Yeah.
and what they mean for the future of, our cities.
Yeah, and I think it's important to note too that this challenge isn't just about like one team winning or something.
Right.
It's a global effort with researchers from all over the world collaborating and pushing the boundaries of what AI can do in these urban environments.
It's really cool.
Yeah.
So, okay, let's jump right into the first track. Multi-target, multi-camera people tracking.
All
Just
right.
probably seeing this in action in those crime dramas where they like zoom in and enhance all that grainy security footage.
Right.
But here we're talking about tracking thousands of people across hundreds of cameras and all in real time.
Yeah, it's a mind-boggling task. Just
Uh,
imagine trying to follow individuals through like a super crowded train station or like a packed shopping mall.
oh my gosh.
This year, the challenge included over 1,300 cameras and 3,400 people. And they even added 3D tracking to make it even more complex.
Whoa, 3D tracking. That's like next level.
So how are these AI systems even doing all of this?
So most teams are focusing on what's called online tracking algorithms.
Okay.
Think of it this way. You're walking through a crowd,
Mhm.
right? And your brain is constantly predicting where people are going to move based on what you've seen in the past few seconds.
Okay.
That's essentially what these algorithms are doing,
So it's all about real-time decision-making.
Yeah.
Based on limited information.
just like our brains.
Exactly.
That's wild.
Yeah.
But is that online approach like actually as good as the traditional offline methods?
Well, it's an interesting race. The top team in this challenge actually used an offline approach, meaning they had access to all the data before making predictions,
Interesting.
and they managed to extract highly recognizable images from each person's movement path, which gave them an advantage.
So they found a clever workaround. But it sounds like those online tracking methods are catching up fast.
Absolutely. In future challenges, I expect to see more teams using sophisticated learning-based methods with architectures like graph neural networks.
Okay.
This will allow the AI to become even more accurate and adaptable in real-time tracking scenarios.
Gotcha. Okay, so moving on from tracking people to analyzing situations. The next track is traffic safety description and analysis.
Oh, yeah.
And this is where it feels like AI is stepping right out of like a sci-fi film.
I know, right?
Yeah.
Imagine a system that can not only like detect a traffic accident, but also generate a detailed report of what happened, like a virtual investigator. The teams in this challenge are training AI to do just that.
So instead of just saying like car hit pedestrian, it's describing the entire sequence of events
Exactly.
leading up to the accident.
The detail is incredible. Think about all the nuances involved in a traffic incident. Speed, weather, pedestrian behavior,
Right.
the surrounding environment. The AI is being trained to recognize and analyze all of these factors.
That's amazing. I could see this being incredibly useful for like accident investigations.
Absolutely.
No more arguing over who's at fault. The AI has like all the evidence.
Precisely. Insurance companies could use this tech to determine liability, and city planners could identify like dangerous intersections or design safer roads based on the AI's analysis.
Wow. So how are they training the AI to understand these complex situations? Are they like staging accidents?
Well, they're primarily using a dataset called the Woven Traffic Safety Dataset, which features staged traffic scenarios with very detailed descriptions.
Okay.
But they're also incorporating real-world annotations from other datasets to make sure that AI can handle the unpredictable nature of real traffic.
Right. You need both. You need the mix. That makes a lot of sense. Speaking of real-world challenges, the third track tackles something we all encounter on the road, distracted driving.
Yeah.
Oh, yeah.
The naturalistic driving action recognition track focuses on developing AI that can identify various types of distracting behaviors in drivers.
Okay.
Everything from texting to eating to even reaching into the backseat.
Okay. That hits close to home.
Yeah.
I admit I've been guilty of a few of those myself. But it's a serious safety issue, and it's fascinating that AI could play a role in addressing it.
Yeah.
What kind of data are they using to train the AI for this? Are they secretly filming real drivers?
No, not quite. They're using a dataset called Cindy2, which features videos recorded from 3 different camera angles inside a stationary vehicle.
Okay.
So they had drivers perform these distracting behaviors in a controlled environment so they could build a comprehensive dataset.
So it's like a more controlled approach.
Right.
And how many different behaviors can this AI actually recognize?
They were tasked with classifying 16 different types of distracted driving activities, which is a significant step up from previous challenges.
16.
Yeah.
That's impressive. So it's not just spotting someone texting, it's understanding the specific type of distraction. That seems like it could be incredibly useful for developing better driver assistance systems, right?
Absolutely.
Yeah.
Imagine a system that not only alerts you when you're drifting out of your lane, but also identifies why you're distracted and provides targeted feedback.
Okay.
It could be a game changer for road safety.
This AI is practically a digital driving instructor. I'm impressed. Now let's move on to the fourth track, which is all about those funky fisheye cameras.
Ah, yes. Road object detection in fisheye cameras. These cameras with their super wide field of view are often used in traffic monitoring systems,
Right.
but they create a unique challenge for AI because of the way they distort images.
Yeah, I can see how those curved lines and warped perspectives would be like a nightmare for traditional object detection algorithms.
Yeah.
So, how are these researchers tackling this problem?
So many teams are using what's called ensemble models.
Okay.
It's like bringing in a whole team of specialists, each trained on different aspects of object detection,
Okay.
and combining their knowledge to create a more robust and accurate system.
So it's like a team effort within the AI itself. That's
Yep.
pretty cool.
Or-
And what are some of the specific challenges they're facing with these fisheye images?
Well, one challenge is that objects can appear much smaller in fisheye images, especially those further away from the camera.
Right.
This makes it difficult for the AI to accurately identify them. The winning team in this track used a clever technique called slicing-aided hyperinference, SAHI, to overcome this issue and improve the detection of small objects.
So they found a way to enhance the AI's vision, so to speak.
Right. That's amazing. And the potential applications for this technology are vast. Imagine a citywide traffic management system that can accurately detect everything from jaywalkers to illegally parked cars, all using fisheye cameras. It could revolutionize the way we monitor and manage our urban environments.
Okay, so for the final track, we're switching gears to something a little more specific. Motorcycle helmet safety.
Oh, yeah.
This track, detecting violation of helmet rule for motorcyclists, focuses on using AI to automatically identify motorcyclists who are not wearing helmets.
Yeah.
This tech could be incredibly valuable for traffic safety enforcement, especially in countries where helmet laws are in place.
Absolutely.
But this sounds like a really tough challenge.
Mm-hmm.
Like real-world traffic footage can be messy, poor visibility, crowded streets,
Yeah.
all sorts of distractions.
You're right, and the data set for this challenge includes all of those real-world difficulties,
Right.
which makes accurate detection even harder.
So how are the teams approaching this problem?
Most are combining object detection and object tracking techniques.
Oh.
They're using sophisticated object detection models like Cody ETR, along with methods like weighted box fusion and test time augmentation to improve accuracy.
So they're basically training the AI to spot motorcyclists.
Yeah.
And then track their movements to determine whether or not they're wearing a helmet.
Right.
But what about that issue of class imbalance? I imagine there are far more motorcyclists wearing helmets than not wearing them in the data set.
Right.
Wouldn't that bias the AI towards assuming that, everyone is wearing a helmet?
That's a great point, and it's something that the teams had to address head-on. Some used algorithms that were specifically designed to handle rare events, while others focused on balancing the AI's ability to correctly identify both helmet wearers and violators.
So it sounds like they're really pushing the limits of what AI can do in this area.
Absolutely. And while there's still room for improvement, the progress we're seeing in this challenge is remarkable.
For sure. It's clear that across all 5 tracks, there's some incredibly innovative work being done. But before we get into the key takeaways from the challenge as a whole,
Okay.
let's dive a little deeper into the technical approaches being used
Yeah.
and how they're really shaping the future of AI in our cities.
I'm ready when you are. Yeah, it's really fascinating to see how these researchers are tackling such diverse challenges,
agree.
from tracking individuals to analyzing those really complex traffic scenes.
Absolutely. And as we've been exploring these tracks, a few key trends have really jumped out at me.
Yeah.
One that seems to be everywhere is the use of ensemble models.
Yeah.
Can you explain what those are and why they're so popular in this challenge?
Sure. So imagine you're trying to solve like a really complex problem, right? Instead of relying on just one expert, you might consult a team of specialists, each with their own unique knowledge and perspective.
Right,
Ensemble models work in a similar way.
right.
They combine multiple AI models, each trained on different aspects of the data, or using different algorithms to create a more powerful and robust system.
So it's like harnessing the collective intelligence of multiple AI brains.
Yeah,
That makes a lot of sense, especially when dealing with these real-world scenarios where there's so much variability and complexity.
exactly. We saw ensemble models being used across several tracks, particularly in that fisheye camera challenge where that distortion makes object detection super difficult.
Yeah.
By combining the strengths of multiple models, teams were able to improve accuracy and handle those tricky perspectives.
It's like having a team of AI detectives working together to piece together the puzzle. Another trend I noticed was the creative use of data augmentation.
Uh-huh.
Can you give us a quick rundown of what that means and why it's so important?
Absolutely. So data augmentation is essentially a way to artificially expand your training data set.
Okay.
Think of it this way. If you're teaching a child to recognize different breeds of dogs, you wouldn't just show them one picture of each breed.
Right.
You'd show them pictures from different angles and different lighting with different backgrounds. Data augmentation does the same thing for AI models.
So it's all about exposing the AI to a wider range of variations to make it more adaptable and robust.
Yeah.
But how are they actually augmenting the data in these challenges? Are they just like photoshopping images?
It can be that simple sometimes, but there are also more sophisticated techniques. For example, in the fisheye camera track, one team used a method called CycleGAN to generate synthetic fisheye images from regular images.
Oh, wow.
This allowed them to dramatically increase the size and diversity of their training data set, which ultimately led to better performance.
That's so clever. It's like they're teaching the AI to see the world through a fisheye lens without needing to collect tons of real-world fisheye images.
Exactly. Data augmentation is a really powerful tool, especially when you're dealing with limited or imbalanced data sets.
And speaking of limited data, one of the most exciting areas of development is the push towards real-time applications, especially in that multi-target, multi-camera tracking challenge. It seems like the holy grail is to have AI systems that can process information and make decisions as quickly as our own brains do.
Absolutely. Real-time processing is essential for so many smart city applications, from traffic management to security systems. While online tracking algorithms are still maturing, we saw some significant progress in this challenge, and I expect this trend to continue in future competitions.
It's fascinating to think about the possibilities. Imagine a city where AI can monitor traffic flow in real time, dynamically adjust traffic signals to reduce congestion, or even predict and prevent accidents before they happen.
It sounds like science fiction, but it's becoming increasingly possible.
Yeah.
The research showcased in this challenge is truly paving the way for a smarter and more efficient urban future.
Okay, so we've covered the major trends, but what about the specific algorithms and techniques being used? Can we dive a little deeper into the technical side of things?
Absolutely. One of the most exciting areas of advancement is in the field of deep learning, particularly the use of convolutional neural networks, or CNNs.
Okay.
These networks are incredibly good at analyzing images and extracting meaningful features.
Can you break that down a little further for those of us who aren't like AI experts?
Yeah. Sure. Imagine you're looking at a picture of a cat. Your brain doesn't process the entire image at once. It focuses on specific features: the pointy ears, the whiskers, the shape of the eyes. CNNs work in a similar way. They break down images into smaller parts and learn to identify patterns and features that are relevant to the task at hand.
So it's like the AI is learning to see the world through a different lens, focusing on the details that matter most for the specific task it's been trained for.
Exactly. And this is why CNNs have been so successful in tasks like object detection and image recognition. In the AI City Challenge, we saw teams using various types of CNNs, including some very advanced architectures like YOLO, you only look once, and DETR, detection transformer.
Those names sound pretty intense.
Yeah.
Are those the algorithms behind those super detailed reports the AI was generating in the traffic safety track?
They could be part of the system, yes. These advanced architectures are capable of analyzing images and videos with incredible accuracy and detail, identifying not only the objects present, but also their relationships and interactions.
So it's not just about spotting a car and a pedestrian. It's about understanding how they're moving in relation to each other and the surrounding environment. That's impressive.
It is. And as these algorithms continue to evolve and improve, we can expect to see even more sophisticated and nuanced applications in the future.
It's clear that this challenge is pushing the boundaries of what's possible with AI.
Hmm.
But beyond the impressive technical feats, I'm also curious about the potential impact on our daily lives. How do you see these technologies shaping the way we live and interact with our cities in the years to come?
That's a great question, and I think it's one that deserves a deeper dive. Let's shift gears and explore the broader implications of this research and what it means for the future of urban living.
Yeah, it really is mind-blowing to think about how these AI advancements could transform our cities. We've talked about safer roads, more efficient traffic flow, even AI that can practically write up accident reports. But what else is on the horizon?
Oh, the possibilities are vast. Imagine a city where AI helps manage resources like water and electricity, optimizing distribution based on real-time needs and usage patterns.
So instead of just like reacting to shortages, the AI could predict and prevent them.
Exactly.
That would be incredible.
And think about public safety. We've already seen AI being used in surveillance systems, but imagine a system that can not only detect potential threats, but also predict and prevent crime by identifying patterns and anomalies in real-time data.
It sounds a bit like Minority Report.
A little bit, yeah.
But hopefully without the pre-crime arrests. Ethical considerations aside, the potential for AI to create safer, more efficient, and more sustainable cities is undeniable.
Absolutely. And it's not just about the technology itself, it's about how we design and implement these systems in a way that benefits everyone.
Right.
We need to ensure that AI is used responsibly and ethically, addressing issues like privacy bias and accessibility.
Yeah, that's a crucial point. We don't want to create a future where only certain segments of society benefit from these advancements.
Exactly. The goal should be to create cities that are smarter, safer, and more equitable for all residents.
Well said. It's clear that we're just scratching the surface of what's possible with AI in urban environments. The 8th AI City Challenge has given us a glimpse into the future, showcasing the incredible ingenuity and problem-solving skills of researchers from around the world.
Yeah, and the research spurred by these competitions is truly paving the way for a smarter, safer, and more efficient urban future.
I'm so glad we took this deep dive. But before we go, I always like to leave our listeners with something to ponder.
Okay, I like where you're going with this.
We've seen how AI can track people, analyze traffic accidents, and even spot motorcyclists without helmets. But what other urban challenges could AI help us tackle?
That's a fantastic question. The possibilities are vast. Imagine AI monitoring pollution levels in real time, optimizing traffic flow to reduce congestion, or even coordinating disaster response efforts.
It's mind-blowing to think about the potential. We're really just scratching the surface of what's possible with AI in our cities.
I wholeheartedly agree. And the most exciting part is that we're not just passively observing these advancements.
Right.
Through competitions like the AI City Challenge, we're actively shaping the future of our urban environments.
So, to our listeners, we challenge you. Think about your own city. What problems could AI help solve? What would a truly intelligent city look like to you? Let us know your thoughts, and let's continue this conversation together.
Until next time, keep exploring, keep questioning, and keep diving deep.